Hey you guys, welcome back to the channel PHYSICSSIRJEE, and this is the video number 2 of the JEE Mains 2019 and 20 extra topics or extra syllabus topics, as you could see on the screen. We are going to discuss the questions, and through those questions we are going to discuss the concepts involved. So this is one of the best ways of preparing for your JEE Mains examination, by actually going through the questions that are required for this particular exam. So these are certain topics: semiconductors, communication systems, classical magnetism, etc., which are usually feared by the students because they have less practice in it, and also they are not there for JEE advanced syllabus. Okay, so without much further ado, in case you have not checked the video one, please go to the video one. Link is in the description below, and we'll be doing 8 videos trying to cover all the 2020 January shift papers and 2019 both April and January shift papers, which are conducted by NTA. So there's a very good probability that the level of the papers in the future exams would be going to be of the same level. Okay, so this video is going to cover, we are going actually backward in case you've been following video one. So we are going to look at 8th January shift 1 and 7th January shift 2 and shift 1 papers. Okay, so as I say, this is alpha and omega of your preparation, the first and last step of your preparation. So this is the first question we are going to look at. Boolean relation at the output stage Y here for the following circuit is looks like a big circuit. So there are some diodes and there is some transistor here. So we need to be able to solve this in parts actually. Okay, so you want to give it a try. Pause the video here, have a try, and come back for the solution. So I'm going forward with the solution now. So the two parts, I'll first discuss the part on the left, which is the diode circuitry. Okay, so this is how I have split that part. Okay, right. So I'm going to check for each of these possible values of Boolean 0 and 1 and build a truth table on the right, as you could see. So when you have a 0 and a 0 here, both of these would be actually in reverse bias, as you could have a positive terminal of the PN junction diode with a 0. So none of these will conduct, right? And then this 0 would conduct through, because this is an open resistor, and you would get an answer of 0. And when one of them is 1, for example this one is 1, then this would be a forward bias condition, and this would be conducting here, and this, once it's conducting wire, this would be a 1. So I think you can now argue that even if one of them is 1, there will be a conducting forward bias diode where the result would be 1. So this is a very simple output circuit where even if one of the outputs is 1, then inputs is 1, then the output is going to be 1. So this is nothing but a OR gate. Okay, right? So uh, these kind of diode analysis for the gates OR and AND gates are not given in NCERT, but you have a very standard textbook called H.C. Verma volume 2 in page number 411. I have illustrated here the same diagram that I have picked it from, so you could see the same explanation that I gave or a similar one. Also it is there for AND gate and also the transistor, which has a good explanation why it is a NOT gate. So due to the length of the video, I'm not going to cover all of this. So please, I request you to go to page number 411. And for any future problems, this would be a very good page to read through. So now that we have ascertained that the circuit contains an OR gate and a NOT gate, let's go back to the problem that we have in our hand. So it would be a sequence of OR and AND here. So this would be OR A plus B, and this is NOT gate. Sorry, I said an AND, it should be a NOT gate. So the result is A plus B, and then you take a NOT of that. And in the video one, I've already discussed how to actually enlarge this one. So this would be A plus B whole complement, which is A complement P complement. Okay, so the answer for this particular question should be 4. Okay, right? You should be very careful about the difference between the third option and the fourth option. So this was a very tough question for JEE mains extra syllabus in 8th January shift 1. But this is the only question that they asked in extra syllabus. Okay, so that was a compensation. And let's move to the next paper, which is the 7th January shift 2. This is a question on hysteresis loop of B versus H graph that you should be familiar with in the magnetic properties of matter. So the figure gives experimentally measured B versus H variation in a ferromagnetic material. The retentivity, the coercivity, and saturation respectively are. So this is just about to read the graph, and actually you should be able to know the meaning of these words and how to locate them on the graph. That's as simple as that. Okay, right? So want to give it a try? Pause, go ahead, and this is the solution I'm going to provide. So retentivity is the y intercept, where it is nothing but if you are increasing the value of H, that is increasing the current, then the B actually increases, but it saturates at certain value. So this is the saturation magnetization, the highest value of B. But once you start reducing the value of H, that is removing the current in that experiment, instead of coming back along the same line, actually the B would be retained by some value. So even after H is 0, that is current you supplied to that magnet is 0, or magnet circuit is 0, the value of B still remains, and that's why it is called, you can see the word retentivity means the value would be remained. Actually there's another name for this, it's also called as remanence. Okay, right? So that when it remains, so that he has given as 1 Tesla here. And coercivity is, if you want to remove this retentivity, you need to provide a H in reverse direction. That means you have to circulate the current in reverse direction in order to get this retentivity to 0. So coercivity, or in English it is forcing that magnet to have 0 magnetism. Okay, so that is the X intercept in the negative direction, which he gave in the question as 50 ampere per meter. And this height, or the maxima, is given as 1.5 Tesla. So going by the required answers, the retentivity was 1 Tesla and coercivity was 50 ampere per meter, and 1.5 Tesla was given. So this is the correct answer. Let's go to the next question, which is from the 7th January shift 2. The two ideal Carnot engines operate in cascade. Cascade is series. All heat given up by one engine is used by other engine to produce work between temperatures T1 and T2. The temperature of hot reservoir of first engine is T1, and the temperature of cold reservoir of second engine is T2. T is the temperature of sink of first engine, which is also source for second engine. By now you should get an idea of how the picture is. How is T related to T1 and T2? Last important line: if both engines perform equal amount of work. Want to give it a try? Pause and then go ahead. Okay, so here's the solution. So first, just have a schematic, simple diagram on your paper where these are the Carnot engines in series, where the sink of one becomes the source of the second one. Also, it's important that he noted that the work is same in both the cases. So we all know in Carnot engine that T of the lower value and divided by T of the higher reservoir temperature is Q out divided by Qn. This actually forms the important equation for our efficiency also. So for the first one, this being higher, therefore T1 divided by this lower T is Q1, which is the value of the input, divided by Q2, that is the output. Okay, so whereas T divided by T2 is given by Q2 by Q3 for the same discussion. Okay, right? And therefore you end up having W being the same, right? W being the same, Q1 minus Q2 should be equal to Q2 minus Q3, right? And so dividing by Q2, you end up having Q1 by Q2, which is T1 by T minus 1 is equal to 1 minus T2 divided by T from this discussion. So you take things on one side, you end up getting T is equal to T1 plus T2 divided by 2. So that is the arithmetic mean that you end up having. So this would be the correct answer. Okay, right? Let's move on to the next question. In the figure, potential difference between A and B is. Now again, any diode question, it's pretty simple. You have to check whether it is forward biased or reverse biased. So you want to have a try, pause, go ahead with the solution, and then come back to look at the solution I'm going to provide. So I keep on saying, even in video 1 also, that diode questions are one of the easiest questions. You should not fear them while attempting in the exam. Okay, so here's the solution. Since he's talking about potential between point A and point B, you have to reduce this part of circuit using Thevenin's equivalent, right? It's E1 by R1 plus E2 by R2 divided by E1 plus R1 plus R2, right? So 1 by R1 plus 1 by R2. So that's what I'm going to do. So the E effective across this would be 30 divided by 10 divided by 1 by 10 plus 1 by 10. So you'll end up getting 15 volt across this. And R effective is the combination of 10 and 10, which makes it a 5 kilo ohm. Okay, right, which should tell you that the positive terminal of this thing is directly related to the positive part of the diode. So I have written A and B. Across A and B, I have written the effective battery and the voltage. Okay, so resistance. So since this is forward bias, this would be acting like a conducting wire, and this becomes a simple loop now. Okay, right. So we can argue that potential difference across A and B is same as potential difference across this 10 ohm, right? 10 kilo ohm. So which is nothing but, you could see this is 1:2 ratio. So 2/3 of the 15 volt would be across that. So answer should be 10 volt. Okay, so I hope that is pretty clear. It's all about noticing that the diode is in the forward bias mode. Okay, next. Another question from the 7th January shift 2. You could see 7th January shift 1 had only one question in extra syllabus, and whereas shift 2 had quite a few number of them. Okay, right. So the electric field of a plane electromagnetic wave is given by E naught into E I plus j by root 2 into cos of kz plus omega t. Okay, right. At t equal to 0, a positively charged particle is at a point x, y, and z given by this coordinates. If its instantaneous velocity at t equal to 0 is v naught k cap, then the force acting on it due to the wave is. Okay, so there are four options, and he's not asking the magnitude of the force, only the direction. So you want to give it a try, go ahead, pause, and then come back for the solution. Okay, right. So here's the solution. If you have noticed and followed my video 1, in which we took the papers from the other shifts, you realize that this is a question actually which is repeated. Okay, so same question but small variations in the problem that was given. Okay, so let's go ahead. At t equal to 0, whatever coordinates are given, it's nicely you substitute in this. So t0 z is equal to pi by k gives you that this is a cos pi. Cos pi is -1, so electric field at that place is given by this vector. Okay, and also I keep saying right from video 1, the two important thumb rules in plane electromagnetic wave calculations is the E is BC and B cap is C cap cross E cap, or you can have any cyclical variation of these unit vectors. They're all three mutually perpendicular vectors. So here wave is propagating in negative z direction. Always notice a kz plus omega t means negative z direction, and omega t minus kz means positive z direction. So here it is minus z, which means the C cap is given by minus k cap because minus z direction. So substitute this minus k cap here, and E direction you substitute, you end up getting B cap direction like this. Okay, so with B bar's direction known both in magnitude and direction, F bar is equal to Q into E bar plus V cross B is the Lorentz force acting on that. You realize one very important thing, that this V bar of the particle is given as K cap direction. So it's almost similar to the direction of light, only with a minus sign. So one thing you clearly notice is that V cross B is parallel to E bar. Okay, right, it's parallel. Why I am not calculating any magnitudes, I realize that I need not waste time for magnitudes. So since V cross B term itself is parallel to E bar, F is parallel to E bar. Okay, so which means it's the force is parallel to this, which is nothing but it's anti-parallel to this because of a minus sign. So it should be very smart in avoiding some calculation, saving time in this particular question, right? So this should be the correct answer. Let's move ahead. This is another question that keeps repeating about the mean collision time, right? Usually asked more in JEE mains than in JEE advanced. So you should be able to understand this. Okay, and this is actually a repeat question from 2015 mains exam. If you can go and check, same question has been repeated in January shift. Okay, right. So the question is all about, under an adiabatic process, the volume of ideal gas gets doubled, it seems. Consequently, the mean collision time between gas molecule changes from tau1 to tau2. Mean collision means the time duration between two successive collisions of molecules. Cp by Cv is gamma, and for this gas, a good estimate of tau T2 by T1, that is the ratio of those times, is given by. You get 4 options. Okay, right? Want to give it a try? Pause and then move ahead. So here's the solution. So the thing about this is that the mean collision time can be estimated to be, he said estimate, right? So don't worry about exactly what the values are. Some people say that the estimate is lambda by VRMS, whether it's V average. Anyway, we are going to take proportionalities. Okay, so lambda is the mean free path, which is directly proportional to the volume. You should know the formula of mean free path, which is inversely proportional to number per unit volume. So directly proportional to volume. Okay, right? So volume divided by average velocity is related to square root of temperature. Not only that, he mentioned it's an adiabatic process, so PV power gamma should be constant, but since it is in temperature and volume, we should be able to rearrange it like this. Okay, right? And one very interesting thing is that he wants the final answer in terms of volume, because volume ratio is given. So I substitute, instead of T power half, this entire thing here, and I end up getting T is proportional to V power gamma plus 1 by 2. So which is going to give you that the volume, if it is doubled, then the ratio of tau should be 2 power gamma plus 1 by 2. Okay, right? So which is interesting. This was the answer that they gave in 2015 mains, but somehow they misprinted the options in the present examination of 7th January 2020. So this was actually a bonus question, because this is not the correct answer. Inverse of that is actually the correct answer. Okay, right? So another one. So this is still January 7th, but it is in shift 1 now. Visible light of wavelength 6000 into 10 power minus 8 centimeter, a weird way of giving the wavelength, falls normally on a single slit and produces a diffraction pattern. It is found that the second diffraction minimum is at 60 degrees from central maximum. If the first minimum is produced at theta 1, then theta 1 is close to. Okay, so this is diffraction single slit Fraunhofer experiment. So I want to give it a try. Go ahead and then come back for the solution. Okay, right? Let's go. So the thing is, second minimum, you should know that it is given by d sine theta. Theta is 60 degrees, he mentioned here, right? Is 2 lambda. Nth minimum is n lambda. Okay, so you rearrange, you get lambda by d ratio, which is important, root 3 by 4. Then he asks for the first minimum. First minimum is given by d sine theta, a new value of theta is 1 lambda. Okay, so you end up getting the angle is given by this. The problem starts here. He has given answers in terms of some degrees, so, and not standard ones also, right? Root 3 by 4 is not a very standard one. So it would have helped students if they knew certain values of sine 18 degrees, root 5 minus 1 by 4, and 22 and a half, which is given by, and even this you don't remember, you should be able to derive from sine 45, and that's what students were expected to do without calculator. So you get this, you realize that the given root 3 by 4 is slightly greater than 22 and a half. So among the options, the best possible estimate, and difficult in the exam but doable, I think, is 25 degrees. Okay, right. Let's move ahead. This is another question that students found slightly out of NCERT textbook. So let's see what is meant by this. Which of the following gives a reversible operation? So you need to know what is meant by reversible operation in a logic gate system. Okay, so he has given a NOR gate, this is OR gate, and this is a NAND gate, and this is a NOT gate. Okay, you have only one input, one output system. Okay, right. So you want to give it a try? Just pause. Yeah, let's go ahead. So the reversible systems are those where if you are, let's suppose, writing a truth table and you put some inputs and you get an output. Looking at inputs, it's always easy to guess the output, right? But imagine someone asks you that I give you an output for that operation. Can you guess the exact values of the input or not? Okay, so if you can do that, that means if there is a one-to-one mapping, as they call it in set theory, if there is one-to-one mapping between inputs and outputs, then only it is called as a reversible operation. For example, if I give you a simple situation of OR gate, let's say, let's suppose I take an OR gate. Okay, you know that the truth table is given by 0 0 1 0 and 0 1 0 1, and if this is A and B, then the output is immediately given by 0 and 1 and 1 and 1. Okay, so if I give you an output of 0, you definitely know that this is the input. But if I give you an output of 1, then you are not sure, because one output is obtained by multiple inputs. So this particular question or this particular gate is not a reversible operation. Okay, so in that scenario, you can realize that any two input, one output gate is definitely not reversible, because there will be multiple outputs, single output for multiple inputs that are possible. So the only possible situation is the NOT gate, wherein you actually get, if it is answer is 1, you know the unique answer for the input, and if the output is 0, you know the unique value. So that's the required answer here. Okay, so you might be wondering, what are the other possible reversible operations that you might actually end up having. So it's slightly out of syllabus, but you should know, as I said, I'm just giving you an example of a 3 input 3 output system, wherein you could see I have written down some operations here where unique input and unique output are actually written down. So if you can build a very complicated logic gate system where 3 inputs are there and 3 outputs are there, and all these outputs you could see none of them are repeating, then only you can say it's a reversible logic. As I said, there should be a one-to-one mapping between the two. Okay, so that's the idea. Just let's hope they don't give very tough question on this particular aspect. Okay, next question. A polarizer analyzer set is adjusted such that the intensity of light coming out of the analyzer is just 10% of the original intensity. Assuming that the polarizer analyzer set does not absorb any light, the angle by which the analyzer needs to be rotated further to reduce the output intensity to be 0. Okay, so this is something related to polarization. You want to give it a try, pause here and then move on. Okay, so here's the solution. All the polarizer analyzer problems, most of the times, 90% of the times that are asked are based on Mayless law. Okay, right? So the Mayless law is all about the intensity that is coming out from a polarizer when polarized light is actually sent into it. So if the intensity is output is I, then it's equal to I naught into cos square theta. Okay, right? Since it is only 10% that is coming out, you can cancel and make it this cos theta is 1 by root 10. Again, similar to that other question where 25 degrees had to be guessed, here it is slightly different, because you know that once cos theta is 1 by root 10, answer is not 90 and 45, it has to be between the two. So, and you know this is much closer to 90 degrees, so maybe you can guess the value is 71.6, but there's a catch. This is theta, which is the angle between the pass axis and that present polarization of light, right? In order to get 0 intensity, you need to make this angle 90 degrees. So if an angle is 71.6 and you want to make it 90, by what angle he said it needs to be rotated? So here's the catch. The angle further that needs to be rotated is 18.4. So by looking at these two complementary angle answers, you should have guessed the value from this particular cos theta. So the required answer after the catch is 18.4 and not 71.6. Okay, right. Let's move ahead. As usual, another EM waves. JEEMAINS loves EM waves, so please make sure you keep doing this. I said the same thing from the video one also. Okay, so let's go ahead. He has given a B bar for a EM wave, a lot of numbers. Okay, so it should not worry you much. This is a J cap, that is more important. Okay, at times they put J cap here or J cap here, so please search for the direction of B bar. What will be the expression for electric field? Okay, right? Since one thing is for sure, E and B, you want to give it a try, have a pause and then go ahead. Okay, so I'm going ahead with the solution. One thing you should notice is this time he was very kind enough, he can actually alter the inner ones also. Okay, right? He didn't here, but as a concept you should know that E and B are always in phase with each other. So E and B are always in phase. Let me write it. So whatever function that you have inside B, you should have the same thing inside E also. Okay, right? So that's one thing that you need to notice. So the thing is, once you notice that part, only things that you need to know, evaluate is the magnitude of the electric field's amplitude and also its direction. So you could see directions are different, magnitudes are different. So the same old trick, E is BC and E cap is equal to B cap cross C cap. Okay, since he has given B cap is J cap And the direction of propagation, I told you already, if this is a plus, then the direction of propagation is minus I cap. If there is a minus, then it's plus I cap. Okay, so using these two and this, you should realize that the magnitude is 9 volt per meter. I think once you get this, elimination will give you the option 1, but just for completeness, even the B cap or C cap gives you a K cap. So both these match with the option number 1. Okay, right. Uh, this is a damped oscillator circuit. So LCR circuit behaves like a damped harmonic oscillator. Comparing it with a physical spring mass damped oscillator having a damping constant B, the correct equivalence will be. Okay, so he's talking about the analogy between electrical and mechanical circuits. Okay, so you want to give it a try, pause. Let's move ahead. So the thing is, if you are comparing with an RLC circuit with a simple spring block analysis with oil, which provides the viscous force, for this FBD, you should be able to write minus B times V, viscous oil force, minus KX force, which is going to push it back. This is going to be equal to MA. This is versus this equation where you do a Kirchhoff's voltage rule, which is Q by C plus IR plus L di by dt equal to 0. Okay, right? So now you rearrange, and A is written as d square x by dt square, then B by M dx by dt, and K into x by M, versus again everything written in double differentials. You'll get this. You compare clearly, right? He's not talking about position versus charge. You can even have those comparisons also for a future question. Look at these. He's talking about only LCR. So you could say that B is comparable to R, mass is comparable to L, and that's the basic way, right? All the dissipation in electrical circuit happens in resistor, and B, which is due to viscosity, is going to dissipate energy. And also inertia of mass in mechanics is related to the inertia of the inductance, which doesn't allow flux to change abruptly. Slightly more or slightly less straightforward thing is that C and K are inversely related to each other. So taking these things into account, you could see that the option is 3. Okay, right. Another question, this time on optical instruments. Okay, so if you need a magnification of 375 from a compound microscope of tube length 150 millimeter, an objective of focal length 5 mm, the focal length of eyepiece should be close to. Okay, want to give it a try, pause, and then move forward. So this is slightly lengthy and difficult, but if you are a good student of NCRT, then I think it should be a cakewalk for you. So the compound microscope, he has not mentioned whether the image is formed at infinity or near point. Okay, so general formula for magnification is VO by UO into D by UE, which becomes two different formulae in two different cases. Okay, so let's look at first of all what is meant by length L. It is not the distance between the lenses, it's distance between foci. I would strongly recommend you to go through, one page is there in NCRT on compound microscope where he describes this L with proper diagrams. Please do refer to it. Okay, so the formula wise, in image tending to infinity case, this formula becomes a simple length divided by FO into D divided by FE. I substitute the corresponding numbers, you get FE is 20 mm, which he says close to. So if you are brave enough, you could have marked immediately this one, but just for sake of completeness, you can go further into checking the image at near point case, where your D by UE will become approximately. So this is actually approximation because this won't be exactly L by FO, but since it is close to, it's fine. This is the required calculation, and here you're actually going to get nearly 22 mm. So since the answers are very far away, maybe you could have made a brave educative guess. Otherwise, this is the complete solution for it. Okay, right. Last one, and a Carnot engine operates between two reservoirs of 900 Kelvin and 300 Kelvin. You could see even he repeats the kind of questions he asks on Carnot engines. Okay, right? The engine performs 1200 joules of work per cycle. The heat energy delivered by the engine to the low temperature reservoir in the cycle is. Okay, so want to give it a try? Pause and then move on. So here's the solution. So as usual, I keep saying, I think by now you would have heard through 4 or 5 problems on Carnot engine, where T high divided by T low is given by Q in divided by Q out. Okay, so Q in therefore is 3 times of Q out, as you could clearly see. And also Q input should be equal to W plus Q out, and therefore Q out is equal to W divided by 2, which is 600 joule. Okay, so this was a numerical question, so answer should be 600. Okay, so that's it for this video. In the next video, we'll take up the 2019 papers. We have finished 2020 in the first two videos. More questions in 2019. I think there were maximum number of papers in both April and January. So we'll move from April then to January. Slightly tougher questions will be there last year. So we don't know what kind of level this year JEE mains is going to be. So we need to be very, very thorough with all these questions. Okay, so let's hope I'll meet you there in the video number 3. And other series that are also there, links are in the playlist in the description below. So please make sure, if once I make all the 8 videos, all the links of that particular videos would be in the description below, along with if you are a student of first year and following this, you should go out and check the rest of the Pathfinder, Olympiad, AITS and Resolved series. They are worth your time for sure. So in case you like this particular video, please do share it with the students who are preparing for JEE mains. It would be really nice help for them, especially during the difficult times that they are preparing at this point of time. Okay, so please do encourage them to subscribe to my channel, and let's meet in the next video. Okay, thank you.